Hey everybody, I just wanted to spend a little bit of time talking about mixtures because I found that mixtures are one of those topics that can be a little deceiving. And also, we're going to have a lab, or a couple of labs about mixtures, and I just want to go through mixtures a little bit more closely. So let's take a look at the two types of mixtures, heterogeneous and homogeneous mixtures. Now, heterogeneous mixtures are things that are chunky or that you can see parts to. So I have examples of all of these types of mixtures down here. And realize that heterogeneous mixtures are something that you can see the parts to and that you can easily pull the chunks out of, or the parts to. You can easily separate the parts. So realize that mixtures, heterogeneous mixtures and homogeneous mixtures, as the case may be, can come in a lot of forms. You can have solids mixed with solids, like in this case where we have soil, and we can have solids and liquids mixed together. In this case, this is like pancake batter, and we can have liquids and liquids mixed together. So there's all sorts of different types of heterogeneous mixtures. Let me show you one in real life here. So I have in the bowl Gorp, good old raisins and peanuts. It's really yummy. Here, right? Love it. Okay, but what we can do is we can sit here, we can separate this mixture. There's the I'm talking with my mouth full. My mom would be so disappointed. So there's the peanuts, and there's the almonds, and there's the M&Ms. Here's the raisins. So we can reach in here. Oh, I picked a bad time for peanut to go down the wrong throat. Anyways, so you can separate these into their components very easily. So you can separate not only the Gorp that I had just then, but for example this. Whoa, hey, oh, I'm letting you too far ahead here. Okay, this dirt, you can take the parts out and physically separate it. Okay, pancake batter, it's a little harder, but you can separate the solid from the liquid. Okay, you may have to filter it or something. I don't know why that keeps doing that. But when you have oil and water mixed, okay, you'd have to do something else. You can't just pull it out with your fingers, but you can definitely separate it. Maybe you have to. Oh, I still have that peanut in my throat. Oh, okay. Maybe you have to suck the top layer off, and then leave the bottom layer behind. Who knows? But these are heterogeneous mixtures. Now, there's two other special types of heterogeneous mixtures, which exist and are very common, but typically we just call them heterogeneous mixtures anyways. There's this guy right here, which is a suspension. It's like dirt and water. A suspension is a heterogeneous mixture that over time, the particles will just settle out of it. Okay, and so again, if you're going to separate these two, you can do it pretty easily. You can just do it like you would brewing coffee. You would, separate the liquid by filtering. It's called filtering. Okay, and then this guy way over here, everybody should know Jello. Okay, Jello is what we call a colloid, or a colloidal dispersion. So this is slightly different because the particles are so small that they are suspended, and they don't ever fall out of the mixture. And so that's what makes Jello set up, is that those gelatins do not fall out over time. So colloids are very small and are mixed throughout, but they can still be separated pretty easily. And then these guys This is a suspension. Okay. Now, the next type of mixture category is going to be a homogeneous mixture. And I have this coffee here as an example. Homogeneous mixture is a mixture that is same throughout. We also call homogeneous mixtures solutions. Okay. Now, these homogeneous mixtures, they're a little bit tougher to recognize, but they can be separated nonetheless. Homogeneous mixtures or solutions, like that solution of coffee, let's say that there's a whole bunch of sugar in it. How could we separate the coffee from the sugar? Yeah, we could boil it. We could boil the coffee off and leave behind all the sugar that was there, okay? And so that's a good way to do it. Now, just like heterogeneous mixtures, homogeneous mixtures can also take many different forms. It can be in many different states. You can have solid-solid homogeneous mixtures. You can have solid-liquid. You can have liquid-liquid. You can have gas-gas. You can have solid gas. However it works, okay? Any combination. But I have a few kind of examples here of kind of the more common ones. Here are plumbing fittings, and they are made of brass. Brass is an alloy, which is a solid solution, two solids mixed together, of copper and zinc. So when you take copper and zinc and mix it together, you get brass. So it's a homogeneous mixture. Okay, it's the same throughout the whole thing. Okay, vinegar. Okay, vinegar is two liquids mixed together, acetic acid and water. Okay, air, this is supposed to be a picture of air. Air is a mixture. We know that air is nitrogen and oxygen and carbon dioxide, but it's also mixed together evenly. Okay, the air that you take, here in or in your house is the same air that you take when you go outside. It's it's pretty much the same throughout. It would be horrible if it wasn't. Okay. Down here is soda fizzing. This is a solution that is a liquid and a gas mixed together. And so, as long as you drink it fairly reasonable amount of time, that homogeneous mixture is the same throughout. That first sip of soda will taste the same as the last sip of soda. As provided you don't wait a year and a half to eat your soda. I don't have another M&M. So mixtures can be separated using physical means. You can take them, maybe a kind of difficult sort of physical means, but heterogeneous and homogeneous mixtures can be separated using physical means. Now, the last thing that I will say is that if you're going to separate mixtures, no matter what we're doing here, whether it's the heterogeneous mixtures or the homogeneous mixtures, we're taking advantage of differences in their physical properties in order to separate them. So here, if we look at the coffee, how would we separate that? Well, we would boil off the coffee to leave the sugar behind. Well, we're using a difference in the boiling point in order for that to be separated. Okay, over here, how did we separate these things? Well, we use their appearance. Here's a little piece of here's like a little piece of rock, and here's some dirt, and here's another little piece of rock. So we're looking at what they look like. Here we're separating them based on density. Here we're allowing them to filter. One goes through the filter paper. The sand here stays on top. So we're looking at the fact that we're looking at the state, that one's a liquid and one's a solid. So any of these mixtures are separated by their physical differences in physical properties. So if in the future, wink, wink, nudge, nudge, you are challenged to separate a mixture, you're going to have to figure out what their physical properties are and what makes them different from the other things that are in the mixture. And there's all sorts of ways that you can do that. So I hope this clarifies a lot of things about mixtures, and have fun.